Hi everyone, welcome to Vedantu J English. I'm Diksha Ma'am, your chemistry master teacher. So everybody let me know in the chat box if I am clearly visible and audible to all of you, because today we are going to complete this chapter, that is electrochemistry. So this is the third chapter that we're going to complete, and I would love to know if you want to start inorganic or organic firstly. Yes, everybody. Everyone in the chat box, everyone. Wait a minute. Yes. So, students, all of you, everyone. Hello. So, let us start the lecture, guys. Now, let us see that what exactly, like how many students have done the homework. Vansh has done the homework, Suman has done the homework, right? And that's it. Only two students have done the homework. Chalo, no worries. So, let's talk about electrochemistry, right? Electrochemistry, we're going to talk about electrolysis today. So everybody, for electrolysis, see, first two lectures were regarding electrochemical cell. Then we discussed about conductance, conductivity, that was a separate thing. Now today we are going to focus on everything about electrolysis, right? So starting from product of electrolysis, Faraday's law, right? In the end, we are going to discuss about the batteries, right? Okay, everyone. So let us start. Yes, everyone. Let us start the class. And first thing is we need to talk about the product of electrolysis, right? So for that, what exactly is electrolysis? If someone asks you what exactly is electrolysis, right? So what exactly is electrolysis, everyone? Electrolysis is electric current is passed through a solution to bring a chemical change, that is called electrolysis, right? Now, what exactly happens here, right? So I'll draw a rough diagram here. Let me just pick out some beaker, or let's say, chalo, I'm picking out this thing, right? Let's say this is the beaker. In electrochemical cell, what we had is, we had in electrochemical cell, we had, wait a minute, yes, let's decrease. I think this much water is enough, right? So, just I'm going to tell you that what is going to happen here. So guys, as I told you in electrochemical cell, I told you about LOAN. That is loss of electron, oxidation, and oxidation is at anode side, and anode is a negative electron, right? And in electrolytic cell, you have LOAP, that means anode is a positive electron. So let's say I have one electrode here, that is anode, right? And one electrode here, that is cathode, right? So now what will happen? The difference is that here it will be connected to a positive terminal of the battery, right? In electrochemical cell, anode is connected to the negative, right? This is anode is negative, right? And here it is, anode is connected to the positive terminal. Right? That is the first difference. Now, second difference is that if I'm saying that this is anode and this is cathode, I'm just writing it here. This is anode and this is cathode. This is cathode. What is the other difference? Can you observe that in electrochemical cell, we draw two separate beakers, right? But here I am drawing only one beaker, right? So that defines that what is the difference, right? We can have only one beaker, in one beaker only electrolysis happens, right? Now here, what will happen? This is positive, this is negative, right? Let's say I'm talking about refining of copper. I'm taking one example, that is refining of copper. In refining of copper, this we take as impure copper, right? This is taken as impure copper and this is taken as pure copper. This is taken as pure copper, right? Now, if you see that what is going to happen here, we know that at anode oxidation happens, right? So at anode, what will happen? Copper will lose electrons and be converted into this solution. So copper will lose electron and it will jump into this solution as copper 2 positive ion, right? And these electrons being negatively charged, they will be attracted to this positive battery here. So that's why electron will start moving from this side to this side. Now, on this side, what will happen? These copper ions in the solution will actually take these electrons. At this, what will happen? Copper ions in the solution will take these electrons and just get converted to copper. Now you will ask me, ma'am, what is this stupidity, ma'am? He is like losing electron, gaining electron. Copper is getting converted to copper. So that's why it is said that it is refining of copper. That means here what you had is in this particular anode is your impure copper, where electrons are moving here. This is your copper 2 positive, and the impure things, right? They will be deposited here as anode mud. Okay, they will be deposited here as anode mud. The dust, the impurities that must be there in this anode impure copper, right? And here what will happen? Copper 2 positive ion in the solution, they will pick these electrons and be converted into a pure copper. So this that we are forming here is pure copper. So that's how electrolysis work, right? Students, let me know in the chat box if that is clear. Hi Ramu, hi Aryan, Gokul. So let me know in the chat box if this particular thing is clear to all of you or not, that how we actually do copper refining, right, through electrolysis. So this is the same process that we use for all the different kind of electrolysis, right? Now the main thing is that in your JEE previous year questions, even the latest questions, you will see that they are asking questions not on the basis of electrolysis but on the basis of product of electrolysis. They will say you have electrolysis of aqueous copper sulfate, electrolysis of sodium nitrate. You have to tell that what is formed at anode and what is formed at cathode. Like here we can see at anode what we have is copper impure, and at cathode we have pure copper. So in the same way, we are going to talk about different product of electrolysis. So let's talk about how do you define the product of electrolysis. So guys, the first thing is that product of electrolysis. See, I'll give you example why we are discussing this thing, right? See, if you talk about aqueous solution of NaCl, what does it have? It has Na positive, it has H positive from water, OH negative from water, Cl negative, right? Now, on the anode side, there will be catch of electron. That means, there will be loss of electron. So, these anions will always lose the electrons, but we don't know which will lose the electron. And on the cathode side, there will be gain of electron, and we don't know out of Na positive and H positive who will gain the electron. That is the choice that you have to make. That is why product of electrolysis, that means overall what is going to be the product here, what will be formed at anode, what will be formed at cathode, for different types of solutions that you will have, right? So in 2025 also, I think in 1 or 2 attempts, they asked you about product of electrolysis. And if you know this, it's not even nanosecond it will take you to answer, right? Okay, so in the end, I'll also give you a trick for it. Now, firstly, we are going to talk about the core concept of this particular thing. So the product of electrolysis depends upon nature of material of electrolyzed or types of electrodes. See, firstly, like what are the electrolytes? Is it aqueous NaOH? Is it aqueous NaCl? Is it molten NaCl? Is it you can say, is it aqueous H2SO4? Is it sodium nitrate? Is it sodium sulfate? Right? So many solutions you have. Every solution is going to have different product, right? Next is the type of electrodes. Now, ma'am, how does it depend on the type of electrodes? Now, basically, we have two types of electrodes. One is inert. Inert is like who is not going to take part in the reaction. Like you have platinum or gold, like these kind of electrodes will not take part in the reaction, right? But if you talk about the electrode is reactive, like this case, if you see this case, wait a minute, in this case, the electrode is reactive. How the electrode is reactive? This electrode is taking part in the reaction. This electrode in the solution, you have CuSO4 solution, right? In this, what is happening? This particular electrode is losing the electron, right? So the electron is taking part in the solution. So if you have, let's say, the solution and the electrode is same, so that is going to react here. Like here you have copper electrode. Similarly, if you have silver nitrate solution, in silver nitrate solution, you have silver electrode, right? That is also not a inert electrode. That is also going to be a reactive electrode, right? So that is there. It participates in the electrode reaction, okay? Now, next is, thus the product of electrolysis may be different for reactive and inert products, right? So product of electrolysis are going to vary if there is inert or your reactive electrodes, right? Now we are going to talk about if it is there, then the next question that arises in your head is, ma'am, okay, these are the reactivity series, okay? So this reactivity series I also told you in last to last lecture. First question is that, ma'am, do I have to remember all these values? No, but some values, when you see me doing all these things, right, making reactions, you will automatically, that will stay in your head, right? So you don't have to intentionally cram it, that will stay in your head. And wait a minute, why the students are so low here? That I'm not able to understand. I mean, what is this, guys? What is exactly this? So should I cancel this class? Let me see why the audience is so low. Beta, ऐसे तो it will be very difficult for me to teach as well. ठीक है? I'll see if the students are not there, then I'll just cancel the class. I'll give you the PDF of this. You can PDF bhi kya I'll give you this blank. I have to write the reactions myself. ठीक है? This much hard work I'll not do if you guys are not interested. ठीक है? Daily on daily basis I can't do this, right? If you're interested, good. If you're not interested, perfect. No issues in that, right? So I'll just end the class now only. वैसे भी सुबह से this is my third class, right? So even I am not like psycho here who is teaching you the third class at 8 p.m. sacrificing my personal life for you, है ना? Everything we have sacrificed. We YouTube teachers, we sacrifice every single thing for you, right? Namda ma'am is taking classes at 10 p.m. right? I'm taking at 8 p.m. Why so? So that you can get marks, right? But if you're not going to join the classes, then I'll just end the class, guys. That's it for today. And I think I'll provide you with a PDF. You guys are very smart. You can go through product of electrolysis. I don't think so you need it. Okay, you are very smart people. You can do it on your own. So you do it on your own. And Faraday law definition I'll provide. And solution and questions will also be provided. This is battery part. That is theory part. So you can do it yourself. From my side, this chapter is over. Okay. from my side, this chapter is over, and I'm very serious about it. We are not here to sacrifice our personal life for you guys when you guys are not interested, right? See, at 8 p.m. if someone is taking classes for you, that matters a lot, right? So, chalo guys, that's it for today, okay? Okay then, bye bye. नहीं नहीं यार, I'm not in the mood to teach. ठीक है, that's not how teacher like feels like teaching, right? So then guys, PDF will be provided. I'll see you in the next class. I'll see that if you guys want organic or inorganic. According to that, I'll take the class. Right? Chalo, okay, bye bye. Okay, so let's start with the product of electrolysis. So guys, this is the electrochemical series that we have. Okay, so whenever we are choosing the product of electrolysis, for example, this is given. Aqueous means water, and this means Na positive and Cl negative, right? I'm sorry, just give me a second. So starting with the again from the start, I think the break is there. Just copy paste this here, just copy paste this here, and copy paste this here, right? What we started with is electrolysis, and in electrolysis I taught you that the anode is always going to be on the positive side. It is connected to the positive terminal, and cathode is connected to the negative terminal. Now on anode, because oxidation happens, so that's why it is going to lose the electrons, and at cathode it is going to gain the electrons, right? So this is the process of electrolysis. But the question that they ask you in the exam is regarding product of electrolysis. That depends upon the type of electrolyte you take and the type of electrode you take, right? So today we are going to see different types of products we are going to talk about, right? So when you talk about the first thing here, um, so in all the cases, there is a one weird case, that is water, that can also undergo oxidation and also undergo reduction. So the first question that might arise in your head, that might be that, ma'am, like how will you tell us that which one should be formed at anode and which one should be formed at cathode, right? So which thing will be formed at anode, which thing will be formed at cathode, that we have to understand. Like this is the anode and this is cathode. which thing will be formed at anode, which thing will be formed at cathode, right? So if I talk about anode here, because at anode oxidation happens, so at anode you will see the loss of electron will be done by anions, okay? So anions will be deposited on the anode side, and at cathode, because at cathode what we will see is gain of electrons. So cation side, at cathode side you will have cations, okay? Now, for example, you have aqueous NaCl, right? So aqueous means water, right? So anion will be OH negative, Cl negative, cation will be Na positive, H positive. So the question is, will Na be converted to sodium? Will sodium be deposited? Or this will be converted to H2? Or this will be converted to oxygen? Or this will be converted to Cl2? So only two products, one product can be there at anode side, one product can be there at cathode side, right? We can't have too many things, right? So we have to choose, right? Now we have to do the selection, right? That means out of these two we have to select, right? Out of these two also we have to select, okay? So while we are selecting things, how to do that? Let's see that in the comment over here, right? So for that, what we will do is we will select it from the reduction potential or the oxidation potential. So whenever I talk about the cations and anions, we know that what exactly happens at anode is oxidation, And what exactly happens at cathode? That is reduction, okay? That is reduction. So now, what we will see at anode, that particular metal or ion you will choose, that is having high oxidation potential, right? That is having high oxidation potential. Okay, high oxidation potential, I'll just write it like this. Oxidation potential. And here, that thing will be chosen which has very high reduction potential. Okay, so this has high, which are product at anode? Yes, that we will see. Right, so here that thing will be used which is having high oxidation potential, or you can say low reduction potential. Low reduction potential. Right, I would advise you for anions, learn only oxidation potentials. Right, now we are going to discuss one by one 5-3 cases I'll discuss, and with these 5-3 cases only things will be completely clear in your head. But before that, you should know one thing about water, that water can undergo oxidation and reduction both, right? So when water undergo oxidation, reduction, that is gain of electron, this is water in reduction. That means when water is reduced, right? In that case, it liberates hydrogen and it gives a reduction potential of minus of 0.83. This is a very, very important reduction potential that you must remember, right? Now, this is in the case of water when it is gaining the electrons, right? Now let's talk about water when it is losing the electrons, right? So where I can identify water, it is losing, over here it will be, somewhere here it will be. Yes, it is not here. Wait a minute. I think it is not here. Chalo koi baat nahi. Let's see if it is over here. No, it is not here. So I'll write it myself. Okay. So how water is written. Okay. So how water is written. So if you talk about water in reduction, and if you talk about water in oxidation, it has two different electrode potential. Okay. This is water undergoing oxidation in oxidation, whatever you like, right? So this is oxidation. So now what we will do, mark this, right? Now what we are going to do here, right? After this, I am going to see that water is getting, I am not writing the full equation. You don't need to learn the full equation, right? I am not going to write the full equation anywhere, right? So I am simply going to tell you what exactly to do here. When water in reduction, it will gain electron and it will be converted to H2. And here the reduction potential is going to be minus of 0.88, right? This is going to be the reduction potential, sorry, minus of 0.83, right? Now, if you talk about this one, water is undergoing oxidation, that means loss of electron. It will give you O2. And in this case, the oxidation potential, we are checking the oxidation potential in oxidation, right? That is going to be minus of 1.23, right? These are the values that you should remember, right? Now, let's understand one thing. There is a term called overpotential. Let's talk about overpotential here. What exactly is overpotential? So, overpotential is that oxidation of water is not at all easy, right? So, to do the oxidation of water, what we have to do is sometimes we have to apply external voltage into it, right? For example, someone who is not at all interested in studying, right? So, you have to pressurize them to study, right? So, that is overpotential that you have to apply here, right? Okay. You don't have to remember the order of this whole thing, right? Okay. Yes, everybody. Okay. So now, when I talk about the overpotential, it is the excess potential given to the cell or to the water so that oxidation can take place. Oxidation takes place. In case of water, this happens, and in this case, it is E, that is overpotential, is minus of 0.23. That is the overpotential that you have to give from outside, externally, right? So total oxidation potential of water, this is overpotential. Overpotential is this much. So total oxidation will be 1.23 minus 0.23, that is going to be minus 1.46, right? So sometimes in the exam they give you that the oxidation potential of water is minus 1.23, but in reality the oxidation potential by adding over potential will be minus 1.46, and we are going to talk about this minus 1.46 only when we are solving the questions here, right? So now we are going to talk about different cases here, right? So let me just take out, because you know these values sometimes can scare you, right? So let's talk about that. Now one by one I'll talk about that here, right? So everybody, first it is going to be aqueous solution of sodium, this. Now I told you one thing, that whenever you talk about any anode, on anode always talk about anions, on cathode always talk about cations, right? So this is what we are going to apply here, right? So on anode, firstly let's write about cathode. On cathode, it will be, because the total ions are Na positive, Cl negative, and there is water that can undergo both oxidation and reduction, right? So first is anode, and then there will be, first is cathode, and then there will be anode as well, right? So in the case of cathode, what we are going to do, cathode will have cation, so this one, Na positive, undergoing Na. That means it is gaining the electron and becoming Na, right? So now when this is undergoing and it is becoming Na, can you see what is the electrode potential? What is the reduction potential? Minus 2.71, right? So I'll just write it here, that is minus 2.71. Minus 2.71. You don't have to remember this. If they ask you, first thing is I'll give you a trick also to remember this. Then what if they ask you something different only, then also you can calculate, but they will give you electrode potential. Some important like water, sulfate, sodium, copper, these you should remember, not every single value, right? So this is minus 2.71. For water, right, when it gains the electron, right, it will be converted to H2. Now, reduction potential for water is going to be what we discussed, minus now, yes, this is what we discussed, minus, right? Yes, minus 0.83. Okay. Now, this is about cathode side. On the anode side, things are very different, right? On the anode side, what is happening? You have OH. You have Cl. Cl is getting converted to, after losing electrons, it is getting converted to Cl2. I am not writing the full-fledged reaction, that is not required, right? So, here oxidation potential of Cl, okay? What is the oxidation potential of Cl? Let's see that, Cl. So, here reduction potential of Cl is 1.36, so oxidation will be minus 1.36. So can I just write it here, minus 1.36, right? Okay. What about water? Water, when it loses the electrons, it becomes oxygen, and here the oxidation potential with the over voltage is minus 1.46. You have to take over voltage also here, otherwise you will end up doing mistakes here, right? Now, guys, tell me one thing, what is the correct one here, right? Okay, what is the correct one? Yes, sure one, sure. So, can you tell me which is having high reduction potential? Obviously, this will have high reduction potential. Which is having high oxidation potential? Out of this has high oxidation potential. So can I say at cathode you will have H2, at anode you will have Cl2. That is going to be the answer for aqueous sodium chloride. Okay, that is going to be the answer for aqueous sodium chloride. Is that clear, everyone? Okay. Yes, everyone. Now, let's talk about the next one, that is electrolysis of aqueous copper sulfate. Okay, aqueous copper sulfate. Now, here what you have is Cu2 positive ions, right? SO4 2 negative ions, right? Third is you have water, right? So, same thing we are going to do. Firstly, I'm going to talk about cathode, right? Then I'm going to talk about anode, right? Then I'm going to talk about anode. Now, when I talk about cathode, on cathode side, you have copper. Now, reduction potential of copper is already very famous. That is reduction potential of copper is very famous already. That is 0.34. You don't even need to remember this. This is a very, very famous thing because it is having positive reduction potential. It wants to get reduced to a very large extent. Water, we have already learned it, that with adding, it will always is going to be, it is with the reduction of water, we will have H2, and the reduction potential of that is going to be minus of 0.83. Okay? Right? On anode, there is sulfate, and sulfate, I would advise you to remember, right? Sulfate is, I think, 2 point something it is. Let me just cross check. Yes, minus 2.01. Okay, so sulfate is SO4. This is important one because you will have copper sulfate. Then you have nitrate is important. Nitrate is very easy, right? You have sodium sulfate, hydrogen sulfate, SO4 2 negative is an important ion. So you should remember this, right? So this will be SO4 2 negative. After losing the electron, this will be converted to S2O8 2 negative, right? You don't need to know this actually. Just remember that after losing, its oxidation potential is simple. You just have to remember this. That is minus 2.01. That's it. Nothing else. Now for water, I am writing it for the fourth time in this lecture. What is for water? After oxidation of water will always give oxygen. So it is going to give oxidation potential of minus 1.46. Now tell me which of the following you can see is actually on the side where we can say that high reduction potential is there, right? So can I say here it has high reduction potential? Definitely, right? So can I say this one is having the high reduction potential? What about this one, which has high oxidation potential? So this has high oxidation potential. Can I say that? This has high oxidation potential, right? So that is the reason what will happen here. In the answer, you will have, wait a minute, in the answer you will have at cathode, copper will be deposited, on anode, oxygen will be liberated. Okay, so that's how you choose the products, right? Next is aqueous copper sulfate in copper electrode. This is same that we did here. So now this we will do, refining we will do. I've just kept it aside for now, right? Because simple firstly we are doing, right? So this is silver nitrate, AgNO3, right? So it will have this is again in the silver. Chalo, let's talk about this. Because now these electrodes are not inert, right? These are reactive electrodes. This is reactive electrodes. So reactive electrodes I'll talk about, but once we'll do inert electrodes where nothing is mentioned. So here no talk is about the electrode that you have, right? So that's why we'll talk about this. This is aqueous, that's why it will have water. Sodium means it will have Na positive, sulfate means it will have SO4 2 negative, right? Now guys, what about cathode and anode? If you generate here, this is cathode and this is anode and this is anode, right? Now talking about the cathode side, you have sodium, right, which is getting converted to Na. Here you have water, which is getting converted to H2. Here you have SO4 2 negative, which is getting converted to S2O4 2 negative. This is water, which is getting converted to O2. Now tell me what will be the oxidation reduction potentials here. Yes, everybody? Everyone in the chat box? Everyone in the chat box? Yes. So for that, what you need is reduction potential here. So reduction potential here is minus 2.71. This is minus 0.83. Okay? These are repeated. This we also did in NaCl. This we also did in apna shayad CuSO4 we did it here, right? Oxidation potential is minus 2.01, right? So here oxidation potential is minus 1.43. Okay? Yes, everyone. Now tell me what is going to be the answer here. Yes, students, tell me what is going to be the answer. Are you able to identify this or not? The one which has high reduction potential will get reduced. This has high reduction potential. The one which has high oxidation potential will get oxidized. So this has high oxidation potential. So can I say at anode you have O2, at cathode you will have H2. Yes, everybody. Can I say at anode you will have O2, at cathode you will have H2, right? Okay, because you see this value is greater, right? This value is greater. Here this value is greater, right? So here we are checking the higher oxidation potential. Here we are checking the higher reduction potential. Okay. So in the similar way we'll do for sulfuric acid. So it is same. What we'll do, sulfuric acid is water, aqueous. Aqueous means water. This means H positive, this means SO4 2 negative, right? Okay. Now, here you have cathode, right? And here you have anode. Now, if you see this here, cathode is there, anode is there. Cathode means cations, right? So here you will have H positive, here you will have SO4 2 negative. Now, simple thing is whether you take from water you are forming H2 or you take H positive you are forming H2, that is the same thing. So it doesn't matter, right? So we know that eventually from H positive it will form H2 because SHE, standard hydrogen electrode, is equals to 0, right? But still you will get H2 only. That means for cathode it is applicable that H2 will be there. What about anode? Here you have S2O8 2 negative. Its oxidation potential is minus 2.01. And here you have water which is giving you O2. Its oxidation potential is minus 1.46. Now, which is having higher oxidation potential? Compare these two. You have this value which is higher than, see, this one is higher, right? So this one is going to be your anode, right? So at anode you will have O2. Okay, everyone, is that clear? Everybody in the chat box, tell me if that is clear to all of you or not. Tell me if that is clear to all of you or not. Yes, everyone? So, now, I have made this chart for you as well because I know that, because see, in the exam, if we can directly answer, we will try to answer, right? But just directly giving the chart will not work because you will have no idea how this is generated. And if they give you surprisingly some new thing, then you will be totally blank, right? So now let's do when you have reactive electrodes, then what is going to happen, right? So this is a cathode, right? And this is anode, right? Now they are saying that you have aqueous solution. See, aqueous solution means here also you will have water that is converted to H2. Here also you will have water that is converted to O2. Okay. Cathode copper sulfate means you will have Cu2 positive and SO4 2 negative, right? So here you will have copper 2 positive ions that is converting to Cu. Here you will have SO4 2 negative ions that is getting converted to S2O8 2 negative, right? Now, ma'am, how does it matter that we have inert, we have reactive electrode? So the matter is that reactive electrode will also participate in the solution now, right? It will start participating in the solution. How it will start participating in the solution? Let's see, right? So when in terms of this, we also have copper that can lose electrons and become copper 2 positive. So now we have three things which are actually getting compared with each other, right? It's not two, it's three now. Three competition is there, right? So now what you have here is this oxidation potential is minus of 2.01, right? This oxidation potential is minus of 0.34, right? And this oxidation potential, see, reduction potential of copper is 0.34. So oxidation potential will be opposite of that. Here oxidation potential is going to be, it is losing electrons. So this is minus 1.46, right? Can you identify if we don't have this, we have inert electrode, then this is going to be the winner. Then this was the winner. Oxygen was actually liberated at anode. But now we have even this. If you draw it on the number line, this is where minus 2 is, this is where minus 1 is, this is where minus point is, right? So that means highest value is going to be of this one. So at anode, you will have copper That's why in the starting, you had copper electrode. That's why I told you in the starting that we will again talk about refining of copper, right? So you have copper, right? If you remember this, okay, chalo pehle let's talk about this one, right? Here you have reduction potential is 0.34. Here reduction potential is minus 0.83. So definitely this is going to be the winner. So here also you will have copper, right? Here also you will have copper ions that are liberated, right? And here you will have copper. Now, have we done the same thing here? If you remember, have we done the same thing here? Wait a minute. Yes. At anode, I wrote this, copper is losing. At cathode, I wrote this, copper is gaining. How I judge that sulfate? That's why I never talked about here SO4. SO4 2 negative is there. But why I am choosing this electrode, reactive electrode? But that is because that is going to participate here. Right? Okay? Yes, everyone. Now, last case here is electrolysis of aqueous silver nitrate. You have electrolysis of aqueous silver nitrate. If you talk about, right, this is your aqueous silver nitrate. This is Ag, this is NO3 negative, right? Ag, NO3. Okay, this is what you have. Now let's talk about cathode and anode again, right? This is cathode, right? This is anode. Now on cathode we'll have anions, cations, that is Ag positive. This is water. What else? Nothing. Right? This will be converted to Ag. This will be converted to H2. I have to choose what I'll choose, right? At anode, what I'll have? At anode, I'll have NO3 negative, right? And then I'll have water, right? Which is converting to O2. Then the third case will be what? Third case will be what? This reactive electrode, that is silver, right? So silver electrode, if I have Ag, in this case, Ag is going to participate and this will be converted to Ag positive, right? So you need to tell me for Ag what is the electrode potential. Let me just confirm this. Yes, 0.8, right? So if you see this, for this, the reduction potential is 0.8. Here it is minus 0.83, right? This will be minus 0.83, right? What about this? Okay, for this you need to understand one thing, that this NO3 negative is a very good oxidizing agent, extremely good oxidizing agent. So that means it is very good in oxidizing someone. It is not good in itself getting oxidized. So NO3 negative will never itself get oxidized. So this is actually a ruled out situation here. That's why I told you it's very easy, because it will never get oxidized. It's automatically ruled out, right? So here this is not eligible to take part in the competition, okay? So here what you have, oxidation potential is, this is going to be minus 1.46, and this, after losing the electron, this is oxidation potential is going to be, what is the oxidation potential is? Minus 0.8. Now, if you see who is the winner here, Ag is the winner. Can I see Ag is the winner? So Ag will be there at cathode. And over here, who is the winner? This one is the winner, right? This has more oxidation potential. So here you will have Ag positive ions, right? So that's how you choose based on whether you have a reactive electrode, inert electrode. See, if in this case we don't have inert electrode, then what I would have chosen? Let's say in this same case, I don't have inert electron, right? You don't have inert electron. Then what would have happened here? Then this case would not be there, right? So then we will have the only possibility, that is, the only possibility that we would have is oxygen. Then oxygen will be liberated at anode. Okay, everybody, clear? Yes, everyone. Yes, students, is that clear? Yes, yes, done, yeah, done. पी लिया है. चल. Okay, that was about product of electrolysis. Now, if you see this, these are all the like different things that we have done. This is the conclusion part. Okay, for whatever we have discussed. See, I know that still you have to again and again revise it. Only then you will be able to remember it, right? Sulfate, you can remember. Sodium, you should remember. Copper, silver, water in oxidation reduction. That much is enough. Nitrate will never undergo oxidation, right? So if these many you remember, easily you will be able to solve any question on product of analysis, product of electrolysis if it's a new question, right? But otherwise, you can remember this as it is. Personally, I would prefer remembering values because sulfate is repeated, nitrate I know, sulfate is here repeated. So I personally prefer remembering the values because values are less as compared to remembering this throughout that which is where, right? So now it's totally your choice what you find easy, remembering the values or remembering values only, not all the values, only values that are here, right? Because these are everything that is there in your NCERT. Okay? Yes, everybody? Chalo. Now, next is Faraday's law. So in Faraday's, we have two laws here. Faraday's first law, Faraday's second law. So Faraday, you must have heard about Faraday in physics as well, right? Faraday is a very free insan, right? So Faraday was like, I will also understand chemistry. I'll also see what is happening there in chemistry. So he was like, what all is happening at anode and cathode? Some mass is getting deposited, right? So he thought that, okay, what I'll do, I'll apply different current, different charge I will give, and I'll see that according to the electricity, because what is happening in electrolysis? You are giving the electrical charge, it is giving a chemical reaction. In chemical reactions, we have deposition of weight, right? Like copper electrode, there you have deposition of copper, deposition of sodium, deposition of silver, right? Gold, all these things can be there. Now, next question was that if deposition is there by passing electricity, so it should be directly proportional. So he said that I will make a relation between this electricity, the charge that we are giving, with the amount of time, let's say for 10 seconds, 20 seconds, 30 seconds, 5 minutes, 10 minutes, whatever is the time. And what is the charge, what is the current that I am giving, right? So based on that, how much weight is getting deposited, and what he found out that there is a direct relation. He said that the weight that is deposited has a direct relation with the charge that you are giving. And what is charge? Charge is current into time, right? Then he said that he gave a proportionality sign here, that is electrochemical equivalence, right? This Z is called electrochemical equivalence, right? What is the formula of this Z? This Z is equals to molar mass by N is the N factor, F is the Faraday that has a fixed value of 96500, and this becomes your, this is IT. And this is your full-fledged law that you have here. And based on this, guys, I mean, there were so many questions. I have not picked, even from the last 5 years, I have not picked all the questions, okay? Because otherwise, we will be doing only Faraday law in the class, right? So I have picked out 3 questions from there. But every year, not every attempt, but most of the attempt, they are asking questions based on Faraday's law, right? So it's a very important law is first law. Second law, not so many questions, but still you never know they ask you this year, right? So that is also very important. Okay, so let's get through that. So this I already explained you. The value is W is equals to ZIT, or it is W is equals to molar mass by NFIT. Okay, not your IIT. It's like if you want to get into IIT, you have to know this IT as well. Otherwise, IIT is not possible, right? So let's see this. Now, what is Faraday? Faraday approximate value is 96500, right? So let's see the questions, because theory they are not going to ask, they will ask questions based on this. So JEE Mains 2022 question is, first is the amount of charge Faraday required. So this is not exactly based on the Faraday law, but it is somewhat related. So I'll just tell you how. The amount of charge in Faraday required to obtain 1 mole of iron from Fe3O4, right? 1 mole of iron from this. So this is Fe3O4, this is iron. So you firstly need to know what is the N factor here, right? What is the N factor here? That you should know, right? By that, if they ask you the charge, you can easily find out by Unitrie's method. I'll tell you how. So if you see this, this is 3x minus 8 is equals to 0. So x will be equals to 8 by 3, right? Some iron atoms, this will see in redox reaction as well. Mixed oxide, this is where iron has +2 oxidation state as well, +3 as well, right? So you can overall find out that this is having +8 by 3 oxidation state, right? And this is having 0 oxidation state. So N factor, or you can directly say here, N factor is going to be 8 by 3, okay? Once you know the N factor, that is going to be 8 by 3. Now see one thing here which is very important. So we are going to apply the like variations here. For that we need to, wait a minute. I just wrote N factor, wait a minute. I'm supposed to write X here. Okay. Now I'm going to tell you a rule of calculating N factor here. See, here they have balanced it. But ma'am, do I need to balance it always? Let's see that, okay? Ma'am, do I need to balance it or not? Right? So if you see that, do you need to balance it or not? For you, that you need to know one thing. What is N factor? N factor is number of atoms on left side multiplied by change in oxidation state. Change in oxidation state. This is the value how to calculate N factor, okay? So if you see this here, if I am saying that this is getting converted to Fe, so if you don't want to balance it, so either you balance it, that is also, I'll teach you in redox reactions, okay? Either you balance it, but that is a lengthy process, right? So instead of balancing, why don't we do this thing? This is N factor is equals to change in oxidation state. See, this is 0, this is 8 by 3. So it will be 8 by 3. Number of atoms of iron on the left side is 3. So it is going to be 8 is going to be the N factor here. Okay, 8 is going to be the N factor here. Now we will apply the unitary method. Now you will see, ma'am, how you have this thing. Okay, so I'll tell you how we have this thing. See, you will, in these kind of questions, will apply unitary method. Okay, so we'll say that for wait a minute, the amount of charge of Faraday required obtain 1 mole of this. Okay. So if you need 1 mole of iron, right, then can I say, actually you need to balance it here. You need to balance it, right? Because otherwise you won't be able to apply the unitary method, right? So you need to balance it. So while balancing what we saw here, this thing, right? That 1 mole of this is giving you 3 mole of iron, right? Okay. So what we can do here is, instead of writing this thing here, right, I'll just, because I don't have space. So what I'll do here is this. Okay, so I'll just write it here, right? Balancing, if you don't know, then it's okay, because balancing eventually we will do it. Like half reaction method is there, oxidation number method is there. We'll do in redox reactions. Okay, so that is a different topic, right? So once you have balanced it, it's not a normal balancing. It's like from two methods only. You can't just do hit and trial method. There are proper steps to balance it, right? So once you have done the balancing, can I say that this, for 3 mole of, from the balancing, what we will see? We'll say 3 mole of 3 mole of charge, 3 mole of iron is produced by how much charge? 8 Faraday of charge. How, ma'am, you told us 8 Faraday of charge? Because here you have 8 electrons, right? And 1 mole of electron is 1 Faraday. That also you need to know. 1 mole of electron is 1 Faraday. Okay, 1 Faraday is nothing but 1 mole of electron. The charge that 1 mole of electron carries is 1 Faraday. Okay, so 3 mole is produced by 8 Faraday charge. Then 1 mole will be produced by 8 by 3 Faraday of charge, right? So you can say 8 by 3 into F. That is going to be the value here, right? The amount of charge in Faraday required to obtain 1 mole of iron from this in the nearest integer value. After solving, you can get it in the nearest integer value. How do you solve this? Put the value of Faraday as 96500. Then solve it. You will get your answer. This is 331000. And that's how you will get your answer. In the terms of, acha, they asked you in terms of Faraday, right? Wait a minute. They asked you in terms of Faraday. In terms of Faraday, they asked you, right? So that's it, right? That's how you calculate this. So for 3 mole, you have 8 Faraday. So for 1 mole, this will be 8 by 3. Okay? Yes, everyone. Now, let's talk about, instead of second law, we'll firstly do some questions of first law, right? Then the next question is, amount current of this much. Now this is exactly based on, that was based on unitary method. This is exactly based on the Faraday's law. So this is the current that you have, right? Flowing for 10 minutes. This is the time that is given to you. Deposits this much of metal. Now they are saying weight of metal deposits is 3 grams. The equivalent weight of metal you have to tell. See, for that, simple, apply this formula. Weight is equals to molar mass by n factor, right? And this is Faraday, this is IT. Now, do you know what is equivalent weight? Equivalent weight is nothing but it is molar mass by n factor, right? So this will be weight is equals to equivalent weight IT by Faraday. So equivalent weight will be equals to weight into Faraday divided by IT. So if you see this here, weight is given to be 3, Faraday is 96500, and here current is given to be 9.65. Ampere is the SI unit, so we'll take ampere only. Time is given to be 10 minutes, so I'll convert it into seconds, right? And that's how, by solving this, you will get your answer directly, right? Okay, so all you have to do is solve this and you will get your answer here. Answer will be 50. Next is JEE Mains 2025 question. Right now, this is a very, very important question, because here what you will see that product of electrolysis also they are somehow asking. Electrolysis of aqueous solution of NaCl. Now, if you don't know product of electrolysis, you will have no idea what is happening here, right? So we know that if you have aqueous solution of NaCl, if you remember, we have NaOH. See, we have Cl2. we have H2, and we have NaOH that is left behind, so that forms NaOH. So in product of electrolysis, we have seen that these at anode Cl2 is formed, at cathode H2 is formed. We have seen that, right? Now they are saying that volume is given to you, time is given to you. Okay, volume is given, time is given, pH of the solution changes to 12. So if pH is changing to 12, can I say pH value is given to be 12? So H positive concentration is given to be 10 raised power minus 12. Right? Next. The current in amperes used for the given electrolysis is, see, current they are asking you. Now you will say, ma'am, how come like Faraday's law is applied here? See, I'll tell you this here, right? How Faraday's law is applied here. So we have W is equals to molar mass by NFIT. I would advise you just remember this thing, right? Because other formulas you can generate from here. Now what they are asking you is, they have given you volume, they have given you concentration. Do you remember molarity? It's a mixture of so many questions, right? So, do you remember molarity? Molarity is equals to number of moles by volume in liter. So, we can say number of moles is equals to, or you can also say molarity is equals to number of moles by volume in milliliter multiplied by 1000. So, you have volume, you have molarity. That is, concentration is there. Number of moles you can calculate from there, right? And these number of moles you can put here. But ma'am, this is number of moles, this is NF. This is the valency factor, right? So how do you answer this? See, can I just take it like this? This is W, I'll take it here, that is M. This is IT, this is NF and Faraday. Now this W by M, given mass by molar mass, is nothing but number of moles. So can I say number of moles is equals to IT by NF into Faraday, right? So now, do you have time? Yes. Do you have current? Current we have to find out. Do you have number of moles? Yes. NF is going to be 1 here in this case because they are saying aqueous solution of NaCl, right? If you see this here, 1 mole if you have, firstly we have to see how many moles we have. Okay. So according to that we will see, right? Okay. So one by one we are going to solve this, right? NF is going to be, we are going to solve it here, right? And Faraday is 96500. So firstly what we have to solve is number of moles. So number of mole is equals to, can we say molarity? Molarity. From here, number of mole is molarity into volume in milliliter divided by 1000. So I'll put this value here. Number of mole is molarity into volume in milliliter divided by 1000. Okay. Molarity is given to be 10 raised power minus 12. Volume is given to be 600 divided by 1000. Okay. You'll solve this and you'll put this value here. So after solving what we got, this I told you, this also I told you, right? After solving the number of moles here they have just directly put it here. Chalo koi baat nahi, I'll solve it, right? Oops, I'll see if there is some blank slide here. Okay. 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 So number of moles, this can we see, this is coming out to be N is equals to IT by NF. N is equals to IT by NFF. So that means current is going to be number of moles multiplied by NF into Faraday divided by time. Number of moles is nothing but it is given to be 10 raised power minus 12. So you just put all the values here. That is 10 raised power minus 12 into 600 divided by 1000. Right? And what is the value for this one? 1, 2, okay? This is 3, this is, let's not get into 3 here. This will be 6 only. Let's say this is 6 only. This will be 10 raised to power minus 13. 6 into 10 raised to power minus 13 will be the value of number of moles. Very, very low value. Okay? Right? This is N. NF is going to be 1 for this one. For NUH, it is going to be 1. Right? Then if you see this here, right, NF, we have put Faraday is 96500. And what is the value of time here? Time is given to be 5 minutes. So it will be converted to seconds. And that's how you will get the answer here. Okay. Okay, everyone. So that's how you will get the answer here for the Faraday. Right? And that's your full-fledged question, full-fledged answer here. Right, everyone? So, after this is the last question, I think, for your Faraday's law, first law. The amount of electricity in coulomb required for oxidation, right, of 1 mole of H2O to O2 is this. Now, they are saying for oxidation of 1 mole of H2O to O2. Okay? So, it will have this way. See, this is 1 mole, this is going to be this. So, for 1 mole, if I am saying it is 1 mole, if this is 1 mole, this is obviously, see, simple thing is, if we say that it is 1 mole, then that means there is 1 O2 negative, right? Then how many electrons it is going to lose? It is going to gain or lose. That you have to identify. Electricity they are asking you in coulomb. That means they are asking you the charge. Okay? Required for the oxidation of 1 mole. Okay? This is what they are asking you. So, this is again done by unitary method only. So, we'll see how it is done. See, simple thing is that we have this particular thing here, right? This is how it looks like, right? So, this is the oxidation of water. If you remember, I also told you the oxidation potential is minus 1.46 here, right? So, now for 2 moles, it will have 4 electrons will be lost. So, for 1 mole, 2 electrons will be lost. That's why we can say N factor for 1 mole is going to be, 2. Because they are specifying that we have 1 mole. So, N factor for 1 mole is going to be 2. Right? Now, instead of this, what you can do is, instead of this, I told you one thing that if you talk about this thing here, that is W is equals to molar mass by, this is IT. So, can I say number of mole is equal to IT into N factor into Faraday? So, this is the thing that you are going to apply. That is, number of moles is equals to IT into N factor into Faraday. IT is nothing but this is charge, because charge is equals to current into time, right? So, this N factor here, we have calculated Faraday, we know number of moles is already given to us, that is 2. So, Q is equals to N into NF into Faraday, and that's how you will give your answer. Number of mole is 1, N factor is this is 96500, and that's how you calculate this, and you will have your answer here, right? Okay. And they are saying after solving, you have to put it in this particular value, that is in the values of 10 raised to power 5. Okay, so you have to, again, first you will solve this, then you will convert it into 10 raised to power 5 value, and then the answer will be 1.93 is going to be the answer. Okay, yes. Okay, students, so that's it. Now, last one is batteries, and batteries, now I'll tell you just overview of that, because trust me, batteries is nothing but its whole cramming. Cramming is there full on, right? So, I'll tell you some interesting things about batteries so that you can read it, because yes, from batteries also question was asked in JEE 2025, right? lead battery. On lead battery question was asked. Yes. Okay. So let's understand firstly what are these batteries. So the use that we have, for example, the battery that our phone has, the battery that is there in the AC remotes, the batteries that is there in the cells. So all these are actually based on the electrochemical cell, electrochemistry, right? So these are all the applications here, right? So first is the galvanic cell are connected in series to obtain higher voltage. The arrangement is called battery, right? So when they are connected to a higher voltage, connected in series to obtain a higher voltage. So many cells are connected in series to obtain a higher voltage. Wait a minute, I forgot to tell you Faraday's second law. Oh, firstly I should tell you that now. So Faraday's second law, guys, firstly this thing, the same, see, batteries we'll talk about. Firstly, let's talk about Faraday's second law, okay? So Faraday's second law stated that, let's say you have this A electrolytic cell, B electrolytic cell, C electrolytic cell. This is connected in series. This is A, this is B, this is C. Now, he said that, for example, the weight deposited on A is WA, weight deposited on B is WB, weight deposited on C is WC. And he said that you want to find out the ratio of this. WA ratio WB ratio WC. He said that this is going to be equal to ratio of equivalent weights of A, B and C. It means you can write it as WA by equivalent weight of A equals to WB by equivalent weight of B, WC by equivalent weight of C. This is your Faraday's second law, right? What they will give you in the exam? Acha, what is, ma'am, equivalent weight? Oh, how many times we have done this? Equivalent weight is equals to molar mass by N factor. That is your equivalent weight, right? Okay. So you can also write the same thing as WA, WB, or you can say equals WC, N factor. This is molar mass of A. This is N factor for A. N factor for A. This is molar mass of B. This is N factor for B. This is molar mass of C. This is N factor for C. Now, why am I writing it like this? Now, I'll give you one example of the kind of question that they can ask you, right? What kind of question they can ask you in the exam? See, the kind of question that they can ask you in the exam is, they will say that you have AlCl3 on one side. On the other side, let's say they are saying that you have Ag. Okay? These two are connected to AgCl, let's say, whatever. Right? This is connected in series. Right? Now, they are giving that AlCl deposited is how much, what is the weight of Al? They are saying that the weight of Al deposited is, let's say, in the question it is, the weight of Al deposited is, let's say, 3.4 gram. Now they are asking what is the weight of Ag deposited here. These kind of questions they will ask you in the exam, right? Now how do you solve this? Okay, how do you solve this kind of question? Okay, how do you solve this kind of question? Let us see that, right? So guys, what we will see here is, if you have, see, you will say weight of Al, weight of Ag, this is molar mass of Al, this is molar mass of Ag, multiplied by N factor of Al, this is N factor of Ag. Same law I am applying here, right? Okay, now, okay, now what we'll have here, see, molar mass of Al, you know, right? Molar mass of Ag, you know. But ma'am, how do I define the N factor? See, this weight of Al also you know. What is the N factor of Al? See, Al always exists. Here it is existing in Al3 positive. So here N factor is going to be 3. Right? Here we know that when you see this here, this is Ag positive, Cl negative. So this is existing in Ag positive. So that's why N factor is going to be 1. And after putting all these values, you will easily be able to solve it. Right? Okay. Okay, everybody. Yes. Oh God, what is happening there, huh? Chalo, no issues there. I can't do anything. You guys waste your time as much as possible, right? हमका कुछ नहीं समझ आवत है, तुमका कुछ नहीं समझ आवत जावत है, ठीक है? बट तुम्हारा करियर तुम्हारे हाथ से जरूर चला जावत है, ठीक है? I don't want to even say anything to you guys. Okay, do whatever the hell you want to do, right? So now guys, let's talk about batteries, right? So batteries is what we use in our daily life, right? So in our daily life, how do we use the batteries? Like in our phone, we use the batteries in like in remotes, in AC remotes, right? Everywhere we are surrounded with these. In cells, we use these batteries in the remotes, right? So in the watches, we have batteries, right? In earphones, in machines, ear aid machines, everything is made of these electrochemical cell applications, right? So based on this, a theory-based question can be asked to you, right? So when galvanic cells are connected in series to obtain higher voltage, then the arrangement is called as battery, okay? So let's talk about this, how they are actually connected in series, okay? In series, we are connecting these cells and to obtain a very high voltage, right? So we have basically two types of batteries. One is primary battery. So primary batteries can be used so long that active materials are present. Once they get consumed, the cell will stop functioning and cannot be reused. Like if you talk about in our watches, right? In the watches, we have a very small cell, right? That cell, if this battery gets over, I can't charge it and reuse it. That's not possible. I have to get a new one. Though it's very economical. It's just 5 rupees or I think 10 rupees, right? But still you can't consume it, like you can't again recharge it and use it. But this never happens to our phone, right? On daily basis we recharge our phone, right? So how do why we recharge our phone, or recharge means charge our phone on daily basis. Why? Because that is a reusable battery, right? So primary batteries are those batteries which are not reusable, like you have dry cell, Leclanche cell, mercury cell. These are the three categories that we're going to study here. Then there is primary batteries. Secondary batteries are reusable. That also I'll tell you. First is primary batteries like Leclanche cell. What you need to do is all these separators still okay, but um, anode and cathode reactions are most important thing that you need to learn, right? So at anode you have zinc inner case, cathode you have graphite rod, and as a solution you have paste of MnO2, NH4Cl and carbon. Okay, so these are the things that you have. Okay, this also they can ask you in Leclanche cell, what is the anode, what is the cathode, right? So that you should remember, and what is the paste, that means what is the electrolyte that you have. Everything here is cramming, guys. All I can do is I can just give you an overview of this, but you have to go through this part yourself also, because I can't make you cram, right? That you can do by continuous revision only, right? So then Leclanche cell at anode, what happens? Zinc will lose the electrons. At cathode, what will happen? MnO2 plus NH4 positive will gain the electron to become this thing, and you will have your NH3 that is released, right? So now electrolyte is this thing, right? So that is the reaction of anode and cathode in the Leclanche cell. Then there is what is the potential, that is 1.5 volt, used commonly in transistors or clocks that we have in that this particular battery is used, right? So ammonia forms a complex with Zn2 positive to give, this thing is not important for you, you can ignore this as well. Second is mercury cell. So in mercury cell, what is the anode, what is the cathode, everything, let's discuss that. So in mercury cell, see, anode is, you have zinc amalgam, right, that is getting converted to ZNO. At cathode, you have mercury oxide that is getting converted to mercury, right? Electrolyte is a paste of KOH and ZNO. This is in the mercury cell, right? And here the voltage is 1.35, which remains like same as long as ions are not involved, it will remain same. So it is used in hearing aids, watches, right? See, that's why these voltages are very low, right? If you see, this voltage is also very low. This voltage is what? 1.5. Otherwise, if the voltage is high, we won't be able to wear it. We won't be able to like have the clock in our houses this randomly, right? We won't be able to hold it, right? So why so? Because the voltage is very low. And even here the voltage you will see is very low, right? Because in hearing aid, someone who has problem in hearing, right? Your grandparents, right? They might be using hearing aids, right? Because they're not, that electrical signal, that's a whole different process, right? But for that, if you give very high voltage, possible nahi, right? So that's why we have this very, very low voltage here, right? Then there is secondary batteries, in which you have secondary batteries which can be recharged again and again for multiple uses, like we have our mobile phone batteries that we use on daily basis, right? That is the most commonly used battery that you use in your life, right? Then example is lead storage battery, nickel cadmium battery. Let's talk about these two. Okay, so lead storage battery, firstly let's talk about lead storage battery. What is that, right? So guys, lead storage battery is very, very important. Based on this, the question they have asked so many times, right? Anode, lead is converted to PbSO4, right? And at cathode, Pb grinds filled with PbO2, that is converted to PbSO4, right? So that is the whole process that is happening here. Here it is losing the electrons, here it is, because here it is +4, okay? Here it is 0 to +2, here it is +4 to +2. So that's why both the formation is PbSO4 only. But here it is from Pb to PbSO4, here it is PbO2 to PbSO4, right? And these two reactions are very important. Directly they have asked this, right? And electrolyte is 38% solution of H2SO4, and this is not used like in a very humanly touch, we can't use it, right? Because you will see the voltage is very high in these cases, commonly used in automobiles and inverters, right? That heavy battery of lead that you have in your inverters, right? That is of this lead storage battery, okay? So on charging the battery, reaction is reversed, right? We know that in our inverter, it's not like battery. Yes, we do have to recharge it again and again. At one point when we are overcharging, then we have to replace it as well. But it's not like at every discharge you have to replace it, right? So this is the overall cell reaction here. Next, last one is nickel cadmium cell, right? This is also important. So it has jelly roll arrangement separated by layer soaked in moist NaOH and KOH. So basically this kind of thing it has. This is the separator, this is the negative plate, this is the positive plate. And in between you have jelly like roll arrangement it is having, right? And here we have cut it to show you that what exactly is this. It has a roll kind of arrangement, right? Longer life than lead storage cell, but more expensive to manufacture, right? Then the overall reaction is this, where cadmium is getting converted to cadmium 2 positive, nickel 3 positive is getting converted to nickel 2 positive here, right? So oxidation is going on, reduction is going on. So that is a redox reaction, right? Now, last one is your fuel cell. That is a quite like environment friendly cell, right? So we'll talk about that, and this has a very high usage. We scientists use it on daily life. Scientists, yeah, like people for these energy generations, they use it on daily basis. Galvanic cells that are designed to convert energy of combustion of fuels like hydrogen, methane, methanol, etc., directly into electrical energy. So directly these energies are converted to electrical energy, right? So it's a very good resource that we have, right? So one of the best successful fuel cells used for reaction of hydrogen with oxygen to form water, right? So that's a very, very, very interesting one, right? That is happening like in our India as well. So in the cell, hydrogen and oxygen are bubbled through porous carbon electrodes. That means the one that have pores into concentrated aqueous sodium hydroxide solution. Okay, you have hydrogen, you have oxygen, you have sodium hydroxide solution, and these electrodes are having pores, right? Catalysts like platinum, palladium metals, these are used for fast reactions, are incorporated into the electrodes for increasing rate of electrode reactions. The cell runs continuously so as long as the reactants are supplied. The cell will run continuously, right? As long as you are applying the electrode. So that's how it looks like. You have H2, you have O2, and what will be formed here? Here you will have aqueous electrolyte, and here water will be taken out, right? That we use, right? So the overall process is carbon is finally divided with this. It is used as a catalyst. Electrolyte is aqueous NaOH that I told you before also. This is the reaction that happens at cathode and anode. See, these are the same reactions that are discussed in product of electrolysis, right? So at anode, you have H2 that is getting converted to adding like OH negative is from the electrolyte that you have used. It is getting converted to water, right? And here O2, when this water you add here and 4 electrons it is gaining, it is getting converted to 4OH negative, right? That's how it is again and again using this process to make more and more water here, right? So overall reaction is this one. This is the overall reaction where from H2 and O2 you are preparing H2, right? Okay. So this is in aerospace. This is highly used. How it is used? The cell was used for providing electrical power in the Apollo space programs, right? The water vapors that are collected there produced during the reaction were condensed after like making into water, right? And added to the drinking water supply for the astronauts, because there they can't be like, we'll have like here we get groundwater, we have oceans on space, you don't have that, right? So how they get from this particular reaction only, so that electrical supply is there, moreover you have water, right? Both the things are taken care of here, right? Okay. So guys, that's it, and this is the question reaction that take place at graphite anode in dry cell. In the dry cell, at graphite anode, what happens, right? In graphite anode, what happens? At anode, what happens? Zinc will lose the electrons, right? So correct is B is the correct answer here. Okay. So guys, that's it for today, and this is the first question for your homework, that is when the lead storage battery is discharged. This is the first question. Second is this one, that is this much fairly concentrated solution of AgNO3 is electrolyzed using 1 Faraday electricity. Weighing or resulting solution, weight of resulting solution will be. See here, what you have is this concentrated solution of AgNO3 is electrolyzed with 1 Faraday. This is given, this is given. Resulting solution weight is what they are asking you here. Okay, so that's it. And I'm not even looking at the charts, don't worry, right? Because I know what is going on there, so there is no point of looking at that. Right, so guys, this is our JEE Telegram channel, right? And you can just scan this code and you can get included into the members of our Telegram channel. And I would love to see you doing homeworks, and I would love to see your comments, if any. And wait a minute, let me just wait a minute. Just give me a second. Okay. So as you can see here, wait a minute. Here guys, for all of you, what we have is our Sigma batch. You can click over here. This is the Sigma batch where we all are teaching, right? And here live sessions are conducted. All these spammers that you see here are not in the DNA, are not in the Sigma batch, right? Because see, I know that on YouTube anyone can join, right? So these people, they not only ruin the mood of the teacher, right? Usually my energy is not so low, but by seeing the comments, I was like, I have to ignore it. In that process, if there is some genuine student who is asking the doubt, we tend to ignore that as well. Why? Because there is so much bullshit going on in the chat, right? So that is the reason I would advise you to get into this batch. This is at a very minimal price, that is 4,999, right? And trust me, these spammers here, they'll not give this money just to spam in the batch. And even if they do, we have the ability so that we make sure that till now it has never happened, right? Neither in DNA batch nor in Sigma batch. All the students are very sincere, right, in the batch. Extremely dedicated, right? Extremely. In the batch, you will see a dedication of the students. There is nothing like, ma'am, you are so pretty, this and that going on in the chat. Nothing, right? Everyone is fully dedicated on what we are teaching, on the doubts, on the quizzes, on the leaderboards. Everyone is dedicated on that thing, right? And that's what matters, right? And things are taken in so much detail that you are totally going to fall in love with the lectures. And after that, mock tests are being taken after every 15 days. You will have test series as well. You will have quick scanner cards as well. In the batch itself, we will also give you, let's say, you have any doubts. So doubt sessions are also conducted there, right? So all these things are there in this batch, right? Mock test, test series, Tattva modules are there in the batch, right? If you want modules, then definitely. It's not only that we provide you modules. We ourselves solve it, right? We take proper sessions to solve the Tattva modules, right? So all these things are there in the batch, right? So, and there is also no option of deleting the message once you have sent it, right? So the thing, see, I know that students are dedicated. Some students really want to study, but they don't want to or they can't afford like really high prices, right? But they are very dedicated, right? They don't spam. They are very dedicated when good material is provided to them. So for them, we have this batch, right? This is a batch so that the students, just 1 year, we are asking you for 4,999 price. That's it, right? For whole year, right? Everything is provided to you. So every aspirant who wants to get into IIT, money will not stop them, right? They belong to middle class family, it's okay, right? Because price is set at a very minimal point. You don't understand Hindi, you don't find any good YouTube channels on your own regional language. English you understand, right? Because exam is also going to be in English, right? So that's why this English batch is there, right? All together it will be in English, right? Okay? Chal. Okay then students, bye bye, take care, and I'll see you all in the next class. Till then, bye bye, take care.